Alright, time for another draftphysics.com video presentation. So sort of a after video. So I did have a conversation with physicist Michael, and everything went fairly well. We did, to some extent, isolate some of the disagreements and all of that, but there's still a lot of fudgy ground, I guess I would argue. He made some claims about predictions that, some are serious, some more off the top of his head, so I'm not going to take them too seriously. The I can't say anything was resolved, but the experiment will do what it's going to do. It'll add some more information. Now, I would argue, as I have repeatedly, that it's rather amazing that we already don't have these answers. We should already know how levers work. We should know every combination of an interaction between a Newton's cradle, like a one mass hitting a two mass, a one mass hitting a three, a one mass hitting a four. We should already have all of this information. It should already be compiled somewhere. We shouldn't have to speculate on, what the answers are, what the truth is. It should already be well chronicled. And I think that's an underlying accusation against physics that they should take some responsibility for and acknowledge they really haven't done any of this groundwork, that the physics is all theoretical and it really isn't grounded in a great deal of proof or evidence. And all they cite, well, one experiment here, one experiment there, and it's not very good science. And I wish I could have gotten that concession out of Michael, but he won't concede. He thinks it all is good science, and somehow it's rigorous and precise and all of that, and I just don't see it. So that's one of the less tractable of our disagreements. But anyway, lots of things to discuss in terms of angular momentum, angular rotation, angular velocity. Lots of terminology, but the fundamental disagreement is, I think, can be isolated to a couple of things. So I guess I'll just do that part first, and then we'll go to a couple of specific points, and then maybe some of the comments, and we'll see where it goes and such. Oh, yeah, I forgot to point out. So in the conversation, I did reference the lever experiment I did, so I'll leave the link to the video of the lever oscillating. So he claimed it wouldn't oscillate, but like I said, I'm not going to hold him too hard to that standard just because I don't think he thought about it, at least under the conditions of the lever I created. Let's just say that. I think it was a pretty standard balance, and so I don't think there was anything overtly imprecise in its construction. But anyway, he predicted basically that it would rotate and that it wouldn't oscillate. And clearly it does oscillate, and in my opinion, it gives some insight into the fact that the oscillator can't have more energy on one side than the other side. It really can't oscillate if there's more energy on one side than the other side. So these are one of those arguments that I'm not saying are being ignored, but I'm just saying they're not being in any way explained away. So it's sort of like the argument that, again, if I took two objects, the light object, the 5-ton train going 10 miles an hour, and the 10-ton train going 5 miles an hour, and I smashed them into each other in a Newton's cradle, for example. So a two mass against a one mass against a two mass going half the velocity, and they crash. All right, momentum says they're the same. Momentum says neither one wins, and the energy just goes back out again, just reversed. And the momentum. But the kinetic energy theory is saying one has twice as much energy. So logically, you could say, why wouldn't it push the collision? If it has twice as much energy, it should push the collision in its direction. And the fact that kinetic energy can't do that is sort of a glaring defect. And the fact that once they do collide, you're going to end up losing some kinetic energy because now the heavier mass is going to have more momentum. And they switch momentums. So yeah, we'll have to think about it. They have the same momentum, so I guess they just bounce back up again. I don't remember. But the point is that obviously you would think the 5-ton train, if it has twice the energy, would be able to push the 10-ton train, and it doesn't. Those little facts, I think, are important little facts. But anyway, that indicate this kinetic energy is a little bit weak, at minimum. Somehow it's not working like if it was real, it should be working. All right, so I'll go to my general points. All right, so I'm contending there's two subjects here that have gotten sort of mixed into each other. And I'm not saying that's anybody's fault, but I'm just saying it's just sort of a fact. So there's the 1/2 mv squared, and then there's this idea, okay, that if you bang something into something else, you can give it more momentum than you started with. So this idea that if I bounce a ball, a rubber ball off a brick wall, and the ball comes back with 100% of what I threw it with, or 99%, that twice the momentum went into the wall. That the wall actually has the momentum. And that theoretically I could give the wall just a little bit of capacity to move, and that it will actually absorb, let's say we start with 100, it will absorb 199 momentums in this direction, and the ball will reflect with 99. And they do this math where they say this 99 is negative, so you take 99 off that and you only have the 100 in the one direction left over. I'm obviously saying these are both momentums in the universe, and you've now changed a circumstance where you had 100 momentums moving things in the universe, and all of a sudden now you have 300 momentums moving things in the universe, and that's not really permitted. Now the catch to what they're saying is sort of, I think it can sort of be understood that it doesn't make a whole lot of sense, because as I make this yield more and more, less and less energy goes into it. And, that doesn't make much sense. I mean, I start getting, I can go to 50% and 150. And the number will go all the way back to the complete conversion, where I hit one ball into another ball, and the one ball leaves with all 100% of the momentum, and this one goes to 0. It just doesn't make much sense that you can't do it in any of the other circumstances. It's only in this complete reflection circumstance. So I would argue that it seems to me that when something doesn't move, it's basically saying I didn't absorb the energy. That's why it didn't move, is because it didn't absorb it. It collected it, the energy went in, but it was rejected, and that's why you get 100% reflection. You only get a 100% reflection because none of the momentum was used. That's why the ball's coming back, is because none of the momentum was used. It just did a U-turn, all right, and it came right back at you. And that's perfectly consistent with understanding elastic things, that they compress and then they re-expand, and the compression is the absorption of the energy, the expansion is the release of the energy. So it makes perfect sense. So basically they're saying if I throw a hard ball at you that doesn't bounce, that the impact is less. So if I threw an aluminum ball at your head and put a little Velcro on your head so it's stuck, they're saying you only got hit with the 100. But if I make it a rubber ball and have it bounce off your head, then they say you got hit with 200. I'm saying I don't think that's the way it works. All right, so this goes to him talking about fulcrums. But anyway, so this NV squared thing, sorry I didn't put the square on there, is kind of different than this. Okay, they have the same catch of using a squared function for this limited purpose, though. It only goes from the 100% to 200%. It doesn't go any further than that. So you can only put 200% into something. You can't put any more than that, because they're always going to judge what you get back, and you can only get back 100%. So if you technically could throw something and get it to come back with more than 100%, the argument would be that somehow more than 200% went into the other object, but you can't do it, so that's the limitation of it. But these are really two different subjects. It's really, this phenomenon really isn't this statement about the fact that the bullet has 2,000 joules and the gun recoiling only has 2. That kind of idea. That somehow, even though they have the same momentum, they somehow have this completely different capacity to affect things in the universe. And I would obviously argue that now 1,000 people pushing on your door with 1 pound is the same as one person pushing with 1,000 pounds. It's not going to make any difference to your door. Alright, so I think that's enough of that. I probably should have framed that better, but we'll work on that. Yeah, so this probably needs to be moved over here. My OBS got a little screwed up. Anyway, alright, so we'll talk a little bit about the lever. Alright, so he's doing the experiment with carts, which, not my preference, but we'll see what happens. So there'll be 2 carts on their tracks, okay, and the idea will be one cart will be pushed into the lever, and the other cart will be thrown by the lever. We can just change the positions and the masses. And so one of the arguments I made previously is this argument that the problem with so we're looking down at the experiment. So the problem with the horizontal lever, it's probably the same problem. I'm still thinking in gravity you're going to have some of the same issues. Is that you do have to move the lever. So the weight of the lever does matter. So if the lever weighs 10%, let's be more realistic and say 20%, no, 10%. Let me just think, 50, 60, yeah, well, let's say 20%, okay, which isn't great. If the lever is 20% of the weight of the masses, then you have to concede that you have to move the lever, okay? That's going to require some of the momentum. So we want to do some kind of perfect experiment where we're taking, 1 unit of distance with a 2 mass, and we're going to put a 1 mass 2 units of distance. Now, the point is that if the lever has to be moved, but the energy you're bringing in, then it's going to degrade that energy. It's going to consume some of the momentum. So if you have 100 momentums coming in, the idea is you're hoping, let's say we had his prediction is, right, so first I'm saying we ought to just test this to see if you can conserve the energy. So you have 100 coming in, you have, if we just do the 2 thing and not bother with the 1 mass for now. So I'm just trying to get 100 in and then get 100 back. So we know I can't get the 100 back because I will have to move the lever. So the mass of the lever is going to have to be given momentum, and so I'm losing that little bit of energy. So this 20% of the mass will be eaten up by the lever. So we can say that we'll have 80% of the energy left over. So the trick would be is that we'd have to move this mass in a little bit, so for it to really have the same energy, because the only energy left is this 80%. So I have to move this in a little bit closer if I have the expectation that I want to take whatever the 80% is and I want to get it all into here. So the hope is that I can get that to happen. I can put 100 in and get 80 out. Now he's saying that half the energy is going to get absorbed even without that problem. That somehow just doing the experiment, the force is going to be consumed and only 50% is going to come out here. So he's predicting that this leaves with only 1/2 of the momentum that goes in. Now I'm going to argue that no, the only real problem is this lever. So the more energy I can put in, the less the lever will destroy, and therefore, and the lighter I can make the lever compared to the weights, the less percentage of the energy it's going to consume, and I can get this number higher and higher. But the point will be is that we can at least figure out from the 2 mass to the 2 mass how much energy the lever ate, And by knowing how much it eats, then we can know when you're going to put the one mass out here, how much closer you have to put it for it to get the 80% you're hoping for. So you're never going to be able to get 100% liftoff or push. You're going to have to get some percentage less. And so that's where it gets a little messy, because he's going to say the one mass only leaves with 3/4 the velocity, or 2/3. And, well, obviously the lever eating some of the energy is going to guarantee that it's going to get close to that 2/3 number. But I'm going to argue that it would have to be 2/3 of the 80%. So it would have to be closer to 1/2 than 2/3, because it's only 80% of the energy's left over. Ideally, this is supposed to, okay, in my opinion, what we're trying to achieve is a replication of the Newton's cradle, where we can do the transfer between a light object into a heavy object. And that's the real point of the experiment. And the argument is that the only thing that stops the Newton's cradle from working is that they don't have the capacity to do the math, so to speak. The faster velocity, the big V, can't be converted. You can't just push the big V into the smaller mass. It has to convert into a less velocity, and so it has to be a smaller V and a bigger M. And that conversion can't happen with a purely elastic collision. But because the lever can change the masses and make them even, so it can make a 2 mass weigh the same as a 1 mass. So by putting it 2 units of distance, I can make this 1 mass weigh the same as the 2 mass. And when they have equal weights, then they can do the conversion. Because one thing, this one will decelerate. Okay, this side will decelerate at exactly proportional faster acceleration over here. This is going to move twice the distance this would. And that is going to mean that for every little movement here that's slow on this side, I'm going to get a fast movement on this side. So I'm going to be able to do the conversion and be able to convert the heavy object into the higher velocity of the lighter object, or vice versa. Alright, so that's part of what's been stated. So the first test will be, how light can we make the lever and maintaining its stiffness to reduce how much energy spinning the lever will absorb. And ideally we just want to be moving the other mass. And I don't see any real problem with the rotational issue, just because we're not really sticking objects to the lever, and the fact is that all it has to do is move this distance at the right velocity. It doesn't have to turn all the way around. It doesn't have any obligation to keep spinning. So once it pushes this other object, ideally it uses all of its energy to do that, to push this side, and all of the energy goes into pushing this side, and so the lever doesn't have anything left over. So it's sort of like using the energy in a spring. I mean, obviously if you pushed something with a spring, ideally the spring doesn't move or wobble or do anything after it's pushed the object, because all the energy got in. And it's only if something screwed up that connection between the object and the spring does the spring oscillate or do something after it did its job. Ideally you want to get all the energy in the spring into the thing you're pushing with the spring. And so I don't think there's any set rule that you're stuck thinking about this lever as being 2 masses, that you have to move 2 masses and cause them to rotate. Because really it's just the 1 mass you have to move, because the other mass isn't really part of the lever. It doesn't stay connected, it doesn't stay attached, and besides that point, either does this object. So the lever itself can stop spinning if it got all the energy into the thing it's pushing. So I don't see that as being a problem, frankly. So yeah, so that's where we are. So his prediction is that this won't, a 2 mass and a 2 mass he's saying half the energy, we'll lose half of it without even talking about the weight of the lever. So I'm just saying it has to be something less than half, because he's also going to have to turn the lever. Because he's saying this energy is going to have to go into the fulcrum. And I guess my argument there was, he made an argument that the fulcrum is going to be absorbing energy as if it was inelastic. And the truth is, no, it's elastic. Fulcrums are bouncing the energy off. Fulcrums don't absorb the energy. So it's like the bearing, when you spin this lever and you have a bearing in the middle, the bearing isn't really absorbing any energy. Ideally, it's basically reflecting it, because it's got an unmovable center. So as long as it's got a rigid center, the bearing won't absorb much, because basically anything that hits reflects. So the fulcrum is essentially elastic, not inelastic, and it will just reflect the energy back. That would be my argument. Alright, so I think that's enough about that. Let's see, I'm trying to think of some other key subject that came up. So I'll pause and think about it. Alright, I'm back. So I did draw this chart the other day, and I'm going to just keep drawing it, I guess, and keep pointing out how this is their claim, and I'm just saying, does the claim really make sense to you people? I mean, do you really think that's what happens? So this is their elastic, what they're saying happens, and he's even applying this to the lever. So in a sense, he's using this calculation to say what's going to happen. And he actually stated in the video that he believes he can make the object on the other side leave with more momentum. So he thinks you could drop something into a lever with 100 momentums, and that you can configure the lever in a certain way where you can increase the momentum coming out of the other side of the lever. Now, I'd say that's bold talk. Now, this is the experiment they always do. So every single case of the experiment, this is the only version I've ever seen anyone do. So I've never seen anyone do the 50-150 version, or the 75-175 version, or the 100-200, the 100-199, let's say. So right before you get to an object that can't move, something that doesn't move, they still say it goes in. So if I have a pendulum, connected to an anvil, and I bounce the pendulum in, so the steel ball bounces and bounces. As I pointed out, their theory is basically saying I can pull this back with 100 momentums, and it will just keep banging into the solid steel, numerous times, 50 times, 100 times, maybe. And with each bang, it's putting twice the momentum into the steel, moving the earth. So whatever I have the steel tied to, I could technically be moving that object with twice the momentum with every hit. And so it would add up to thousands of momentums. So I'm saying that doesn't make any sense. We don't see anyone proposing a rocket engine that uses that mechanism. Like I said, the whole argument is that this stuff implies free energy. And frankly, if it happened, we'd have free energy, I'm arguing. But anyway, so this is the only one we get. And so I have suggested to him that if you're going to do these experiments over and over, try it with much heavier masses and see if you can get this 175 number, or the 200, the 199 number would be the ideal. So they're basically saying I throw a rubber ball at a wall. If the wall doesn't move, I get 100% of the energy, and 200% goes into the wall. So if it yields just a tiny bit, then 199 goes into that yield, and I still get back 99. And I'm saying the logic really is saying that whatever you're getting back as a reflection is just that, a reflection. It didn't put any energy in. That's why you got the energy back. You don't get it back if it goes into the object. So I'm certainly arguing that if I throw a ball against a surface that moves really easy, I don't get anything back. And the wall certainly doesn't move, with more momentum than the ball had. this doesn't make much sense. There's only 100 momentum. There's only 100 atoms moving, you could argue, and I can't make 103 atoms move that way and then 33 move that way. And I certainly can't make 200 atoms move this way and 100 atoms move that way when I started with just 100. You could sort of understand that I couldn't duplicate this experiment by hitting two things in a different direction. You know, if I banged into, I can't quite see that. If I banged something into, two balls and knocked them sideways, I can't make this extra velocity. I can't make all of this 300 momentums. I'm only going to get 50 and 50. All my momentum's going to get used up hitting the other objects. I'm not going to have anything left. I'm certainly not going to bounce. So none of that's going to happen. I have used other examples. Simple cylinder. Okay. You can't quite see that. And all you have to do is, seal one side, and what are you going to say is going to happen? If I open both sides and I have an explosion, and I let a ball fly out both sides, you're going to say, yes, the air pressure, I'm just going to put air pressure in. The air pressure is going to move both cylinders, okay, at half the speed. And if I just have one side open, just one cylinder to move, and I have the same air pressure go in, then I'm going to get twice the velocity. Because it has to fill the same space, and there's only one thing that moves, so the volume has to be filling the space at the same rate, and it's only going to be able to yield in one direction, and so that one direction is going to have to go twice as fast. So the same force produces twice the velocity when I'm only shooting one object, kind of obviously. Alright, I don't think those are arguments that have in any way dealt with or are in any way debunked as, problematic for this theory. But anyway, so that's what really we're talking about. Is this isn't so much the kinetic energy theory as it is the double your momentum theory. And I just don't understand where it comes from in terms of how people can visualize this function where the rubber ball that bounces back somehow puts double energy into the thing I threw it at, when it seems so obvious that the whole point of the rubber ball is it's preventing the object from absorbing the energy, and I'm just going to get the bounce back. I'm just going to get my energy back because the other object didn't absorb it. I mean, the tennis ball hits the brick wall, the tennis ball collapses. And it re-expands and everything goes this way. How can there be another twice as much momentum going into the wall? Doesn't make much sense to me. It doesn't make any sense, frankly. And like I said, I could set up circumstances where if I want to get that huge reflection back, I could just throw the object back with the same energy, and you're just going to be creating tons and tons of joules. Like I said, something could just bounce back and forth in a spaceship, and the argument could be, well, it's pushing on both surfaces and with twice as much energy than it has. And what sense could that make? And it keeps doing it theoretically perpetually. I don't think that makes much sense. So anyway, all right, so we'll do a couple of comments, and again, I'll link below to my video and to this discussion video and such. You have to like physics to find all this stuff interesting. Some of it's a little detailed and complicated, but I think it was an interesting conversation. So anyway, all right, so let's see what we have for comments. So this Merker guy has always got to be rude. He's always trying to dox me. I mean, so here he quotes Mark Twain with a really bad Mark Twain quote, frankly. Never argue with stupid people. It's just kind of a silly argument to call me stupid when I'm probably more informed on these subjects than anyone you could mention. I mean, who do you know that knows more about Leibniz, Madame Chartelet, or any of that stuff? Who? Who do you want to challenge me on a know the facts test? But anyway, they will drag you down to their level and beat you with experience. So I think Mark Twain was actually being satirical. I think Mark Twain had a great deal of respect for experience. So I think he's sort of joking. But whatever. All right. You think that's a great quote? I think it's a pretty stupid quote, frankly. So you're just explaining how you're stupid. All right. Great job, both. Very civil overall. You guys work well together. Well, the point is we can both make arguments on the fly, fairly coherently. So it's not, not everybody can do that. Okay. So after reading the title, I thought for a moment this was dedicated to whatever that is, spin launch. And that's, I guess, the thing they're building to see if they could launch things into space by rotating them really, really fast and then letting them go. The obvious point to make would be whatever you're putting in there can't be very delicate because it's going to have the shit kicked out of it by G forces alone. Are you doing something you're doing something very valuable. I wish you a fast development of the channel. It would be good if the channel is going to be devoted to expanding the evidence pool and not just doing the same stuff they've already done. And because frankly the evidence pool is pretty dry. Okay, it's there's very little water in it. Frankly, there just isn't. Can't swim in the evidence pool. It's so thin. All right. It's an easy way to defeat draft science claim that standard physics and KE can make a free energy machine is to show that the velocity in one direction goes down with each impact. That's only because of friction, heat and different things like that. So that's just a nuisance. How does that prove that MV is valid? I mean, I just made the point. I can end up putting 2,000 momentums into the wall, and I only started with 100. I just push with 100, and I end up with 2,000 in the wall. I mean, what are you talking about? How did you disprove that? Okay, even though MV goes up. So, as soon as you are taking near the entirety of the time waiting for the next impact. So he thinks it's going to take a long time if I have a 1 mass hit, a 2 mass hit, a 4 mass hit, an 8 mass hit, a 16 mass. He's saying that it's going to take too long for them to do that. They can be a millimeter apart. It doesn't matter how far apart they are. How could it take any time at all? I mean, it's sort of a ridiculous statement. Also, I've watched the video of his oscillating lever experiment. I'm pretty sure the video shows less than 20 oscillations. Well, I have it hanging over there, and frankly, a little bit of wind starts it oscillating, and it just goes on and on and on. But whatever. Much less than the 100 he claims. So I don't know if you can see that in that video, frankly, because I don't waste time just watching the lever oscillate. Yeah, but whatever. But maybe he just didn't upload the rest. Well, of course I didn't upload watching whatever 3 minutes while the lever settles to 0. The key for me though was the weight of the bar. It's a hollow aluminum tube, extremely light. I mean, we're talking a couple of ounces. I think it might be a 5 or 6 foot black steel bar. No, I pointed out what it was in the video, so I guess you didn't listen to the video. So that's pretty funny. I don't know. It's not 5 or 6 feet either. It's about a meter. Okay, at least this is the closest match I could find to Home Depot. So whatever that is. and the weight of such a bar was maybe 5+ pounds. So who knows? See, people just make up stuff. There's nothing you can do about it, and it's okay. That's what you just made up a story. It really isn't at all fact-based. I think even in some of the video you can see that the tube is hollow. I mean, it's hollow. Okay, while the weights of the magnetic ball bearings he is using appear to me to be maybe an ounce or two each. They're solid steel. Hard to say. I'm just saying if I had 4 of them in my hand, they're going to weigh more than the lever. So, just saying. It looked at the weights of similar sized bearings it could find online. Yeah, and I think the bigger the bearings, the greater, the better. But I'm just saying, how would it change anything? If I had twice the size ball bearings or 5 times the size ball bearings, how would it change anything? I think it would be preferable to have more weight than less. It certainly isn't going to bend the aluminum bar. It's a pretty solid bar. I mean, it can probably take 10 pounds without bending. I think this is important, as you can imagine that if a highly massive lever does perfectly oscillate, then adding a few ounces to either side will be negligible in slowing down the apparent perfect oscillation. So again, none of those things you're claiming are true. And it oscillates perfectly without any weights on it. So I don't know exactly where your argument goes. I don't see how it goes anywhere, frankly. Yeah, I don't see it. I don't see how it changes anything pointed out, which is that if I stop the lever in space, I just make the lever stop. The idea is that you can't undo the motion. And the fact is that the thing would fly off. One thing would fly off at twice the velocity of the other thing. There's just no denying it has to leave the lever with twice the momentum of the other object. Not twice the momentum, sorry. Twice the velocity. Shit. Okay, the same momentum, twice the velocity, which means it has to leave, in that case, because I did 4 times the distance, with 4 times the energy. Oh, not bro. What a jackass. Anyway, it's just so disappointing. Let's see. Gary's lever only oscillated because the masses, including that of the steel bar itself, so again, it's not steel, it's aluminum, were well, actually, it has to be steel because it was magnetic. So, yeah, you're right. It is steel. So, it's just saying, it's a hollow steel bar. It's not solid. We're suspended below the pivot point. We're suspended below the pivot point by virtue of him attaching the string or whatever it's suspended off of through a hole in the upper part of the bar. So again, the hole's in the middle of the bar, and now technically the string can move a little bit, so you can really get it to the exact middle or a little bit above, but frankly none of that's going to matter, so you can pretend that matters. It doesn't change anything. The argument is that it does oscillate. This minutia doesn't change anything. Okay, there are 2 other places he could have suspended it from. The point is that lever, the intention is to create a lever that does that, okay, and just put it horizontally, and you're just saying, I just want to smack it with a weight and see what it produces on the other side. What's so complicated? You made one. You had a spring on one side, the same force, and you launched objects. You didn't have some great difficulty doing that, so why are you pretending this is complicated? Okay. The bottom of the bar, in which case it would have simply rotated back to the suspension point being at the top, and once again would oscillate for all the reasons Ian Gosling explained. So this is just all mush in some detail about 2 weeks ago. So it's just mush. From a point just below the dead center of the bar's thickness, it really wouldn't matter. I could put the hole anywhere. I could put it at the bottom of the bar, I could put it at the top of the bar. The thing is still going to oscillate. Okay, according to his masses, because the fact is the fulcrum is so small, because I'm using just a thread. That's the whole point. I'm using a thread. It's a tiny fulcrum. So you can't take any advantages on the fulcrum because it's such a small circumference. It's such a tiny circumference that you don't have to worry about moving an arc across a big bearing. So that's the only time what you're talking about matters, is if the fulcrum has a big circumference. My fulcrum has such a tiny circumference that none of this crap can mean anything. I could have tied the lever with a knot at the top. I could have just tied a loop around the lever and it still would have done the same thing. All right. I.e., according to his, I don't know if there's much point, his mass is being suspended below the bar so that there was exactly the same total mass above and below the pivot point. In that case, it would not have oscillated. So the only reason why it's oscillating is because of the fact that it is actually a bar and you're moving it. And you have to account for the fact that, frankly, when you do move it, you put more mass above the fulcrum. You can't tilt it without more mass being above the fulcrum. So it's really just the mass of the lever that's the problem, technically. That's why the lever itself, without any masses on it, oscillates, is because you end up putting more lever above the fulcrum. Okay. Other than some unintentional and irrelevant swing side to side due to his string or whatever being suspended from, making it a pendulum. So he's arguing it was a pendulum. It wasn't a pendulum, but anyway. Had he done it, he could have lifted one end or the other and let it go, and it would have dropped back to the horizontal position, let alone oscillated. So that's all lies, okay? I did it all kinds of different ways. I poked it, I lifted it, I do it all kinds of ways. It balanced perfectly. So this is all just bullshit. The way he's just going to go on and on, right? This is really is this worth anybody's time? The way he suspended, the point was just to show the fact that it works. The fact is that it's an oscillator. And the oscillator, in fact, okay, the oscillator, that means oscillators are known for the fact that you're throwing the energy one way and you throw it back the other way. That's what an oscillator is. And so it's just a fact that it's oscillating with 4 times the energy on one side than it's on the other side. All right. The way he suspended the bar, it would have oscillated even without the extra masses suspended. Yes, of course. I already said that right away. In that case, he'd have suspended it from the point dead center to the bar's thickness. The point is that according to the lever, yes, it oscillates with no weights on it. And it considers it exactly the same when I have the weights on. So when I have the tiny mass very far down the lever and I have the big mass close to the fulcrum, it considers them both the same weight. And it oscillates perfectly. It's weighing them and saying they weigh the same amount. Duh. They're applying the same torque and force. Oh, I mean, these people are just so hopeless. Oh, look at all this crap. It would have been a cleaner experiment if the fulcrum was a fixed point. It was pretty fixed, frankly. Not able to swing sideways. Rotating this way didn't have anything to do with anything. I mean, it oscillated fine without. It didn't slow it down any. It didn't do anything to harm it in any way. But that requires the kind of effort. So he's just going to go on about mindless marvels of grotesque morons. It would have also helped a little to not have a giant plant in the shot. Again, it was only for one purpose, just to show that there's a stick oscillating with one mass on one side and 4 masses on the other side. And it was just for that purpose. And that's what it did. Oh, you people are just so pathetic. And for the bar not to be free to rotate horizontally. And for us to see some close-ups of his suspension point. Again, all of this is, I could have tied it a knot, and it wouldn't have made any difference at all. But whatever. Suspended from a larger pendulum test I did shows that this shows the oscillations. So again, they're doing these oscillating experiments using springs, trying to find all kinds of ways to show that somehow the 5 mass doesn't equal the 10 mass in weight when it's twice the distance on the lever. They're going to keep claiming, even though the lever says, the balance says they weigh the same, they're going to keep arguing that they don't weigh the same. That somehow the 5 mass has more inertia, whatever that is, and somehow the fulcrum can see its inertia panties, and it knows it's a fake, and that it's harder to push. Because it's a light thing, it's harder to push. I mean, it makes no sense. These arguments are silly. Let's see. It would have also helped if he addressed these issues and had a second go. I already pointed out why I stopped doing experiments is because of this very fact that they should be done very well. That's my argument, is that the evidence should be above these critiques. There shouldn't be crud on it. And you should be able to read the rulers and all of that stuff, okay? The experiments really should have a plant behind them. All of that crap should go away, and we should have quality experimental data. Like we always do when he criticizes our work, then he could see for himself that his first and only experiment, so this wasn't my first and only, I made the ballistic pendulum, I shot the little ball bearings, I've done plenty of experiments, and again, the very point is that none of them, these little rickety rubber band launchers and this and that, none of it's good enough. Okay, I made a fucking air tube track. It's a pretty cool invention, frankly. Okay, it's, you know, in some ways I think it could work if I worked on it a bit more. But that's the whole point. It's how much time you're going to invest in something, especially something loud and obnoxious. We don't believe it's because we have made the required amount of effort to check all these things numerous times. So again, there's no checking anything. There's no volume of experiments. There's these rickety, shitty experiments, this little nuanced thing. Again, no accountability from this little weasel. The physics he's defending in 350 years hasn't bothered to prove with an experiment that it takes 4 times the fuel to go twice as fast, or that it takes 9 times the fuel to go 3 times as fast, or that it takes 16 times the fuel to go 4 times as fast. They haven't proven any of that in 350 years. And they expect nobody to criticize and say, well, why don't you have a decent experiment proving any of this crap? You make this assertion that this is a fact. I have to pray to this totem pole because you say it is God. MV squared is true and real. Although I can't show you any direct evidence of it doing a damn thing on Earth. I'll never show you the bullet moving 2,000 times more atoms. I'll never show anything demonstrating that this KE crap has anything to do with reality. I'll never show you it starting a forest fire or doing anything, doing any work at all. I'll never show you again, taking 16 times the electricity to make a motor go 4 times as fast. I'll never show you that. All right. Gary hasn't because it's easier to not do the experiment again properly. So what experiment did I do improperly? I showed a lever. I showed a balancing. A thousands of years old balance. Why should I have to even make one in the first place? Why would I have to even illustrate the point? Everybody should understand that, yes, for thousands of years, human beings have measured things with a balance. A stick on a fulcrum. And more importantly, then he has to explain why it no longer does what he claims. Then he doesn't have to explain why it no longer does. I don't even know what that means. Fuck you. The lever's right over there. It's working fine. Okay, if he had to retest it properly and found these things out for himself, he would not be able to keep telling people. So again, find what out myself? What nonsense are you arguing? Again, there's nothing that lever can tell me beyond what it's already shown me. Is that, yes, 4 objects 4 times the distance weighs the same, and that it will oscillate if I provoke it with energy, and the oscillations will continue, and one side will move the 4 masses with 1/4 the velocity of the 1 mass. I did the experiment. It oscillates 100 times because it wouldn't oscillate even once if he did it properly. I did the experiment and it oscillated 100 times because it wouldn't oscillate even once if he did it properly. So what the fuck could that possibly mean? Oh, and then Farley chimes in. Show that the velocity in one direction goes down with each impact, even though mv goes up. This has been pointed out to him numerous times to no effect. What effect could it have? What are you talking about? He keeps conflating the words momentum and energy. Yeah, I'm trying not to do that anymore. But clearly you're just as cheaty. Why don't you, every time you say energy, why don't you say kinetic energy? You don't believe in any other kind, so why don't you just give it a proper title and say kinetic energy? Why are you saying conservation of energy? Why don't you say explicitly conservation of kinetic energy? Because you don't believe in any other conservation. Switching back and forth sometimes, even in one sentence. Yes, to me, energy, if Newton was alive today and the word energy was around, I'm sure he'd want to call momentum energy. All right. I mean, it's just too ridiculous a gripe. Let's see. I think you did the best job you could, Michael. So this is coming from the Gosling tub of crap. So he says it went as well as I could have expected, and I do appreciate Ref Science participation. So that's kind of a nice little statement. Yes, I understand the motivation. I don't really. Beyond the fact that obviously I've challenged him and he feels obligated because I've made a challenge. And so a lot of it is just defending your space. I mean, I'll defend myself also, defending your beliefs. So I like that he has stood up and said, well, I'm not going to let you say this and that. I'm going to show you or prove you wrong. Because really that's what has to happen. The argument has to take place. It's just bullshit that 300 years ago everybody weaseled out. Because that's why you ended up with a duality, is because everybody just weaseled out of the argument. Alright, well, it's not really what happened. In the 1800s, they decided to say it's semantics. They decided to say there isn't anything real to be arguing about. There is no dispute. They can both be alive. Momentum and KE can live in the same little house, and they can use the same silverware and the same plates, and blah, 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 blah. When, no, they really can't. The lure of provability leading to a powerful tool for predicting nature's behavior. So again, this idea that they are standing on some mountain of evidence. They're standing on a mountain of nothing. And this kind of whatever liar cheater, he did an experiment where the results came exactly as I predicted, and he wouldn't show the experiment. So there's an experiment out there that we don't get to critique. He says it's completely wrong, and he just tells us it's completely wrong and it's completely broken and it didn't work right because the answer came out confirming exactly what I said. So that's how he plays. Okay. Then wanting to be able to share and demonstrate it's working with others, only sometimes others may resist that understanding at all costs. So again, this understanding, I'm not resisting anything. I'm a juror at a trial. You have to prove your case. All right, and you're just arguing from authority. You're just saying, well, we all believe it, so why don't you believe it? None of us need evidence. Why do you need evidence, you silly person? I mean, it's just such a bullshit argument. All right, at 35 minutes in, I realized that they were both talking about different experiments. One without gravity and one with gravity. I don't think that really happened, frankly. There is a difference, so maybe a lever experiment should be done in the I don't know even how you could have watched the video. He showed it in the horizontal position. I argued for that previously. He was perfectly aware that I was arguing for that. When I was talking about using pendulums, I'm talking about using pendulums in the horizontal, hitting the lever horizontally. I don't know how else I could use a pendulum in any other position. So, god damn. Sorry, but you're just not paying much attention there, JG. I did respond to some of his comments on another video, and then I deleted them, so maybe I'll attach that video to this video. So frankly, this video is going to be really long, and there's responses to some comments I just thought were just too irrelevant to bother with. Anyway, XY plane instead of vertical Z plane. See, we've already been over that. I mean, I frankly already pointed out the disadvantages and advantages of the two ways of doing the experiment. And clearly the big disadvantage of doing it in gravity is that when you drop something, you're not only dropping it with its acceleration from gravity, but you're dropping it with its weight. So you have to cancel its weight out to figure out what the actual energy is that it hits with. Also, I noticed that DS doesn't understand moment of inertia. Well, I certainly don't understand this moment of mass, was what that's stating. There's no moment of mass. There is no moment of inertia. It's just mushy baby talk, frankly. And I certainly do understand angular velocity in the sense that I understand that, okay, different parts of a wheel have different velocities. So it's kind of silly, I think, for both physics, Michael, or you, to say there's such a thing as angular velocity that could mean anything to anybody. The fact that the inside of the wheel goes around the clock at the same amount of time in the same amount of seconds doesn't account for the fact that the stuff on the outside is moving hell fast and the stuff on the inside is moving hell slow. It's a useless term. There is no angular velocity. I understand that there are different concepts to grasp. Difficult? No, they're silly. But I thought that by now, after talking about it a few years, DS would have learned the basics and would have been prepared for this discussion debate. Frankly, I did just fine in the debate. You know, he's the one that said a couple of things I think he's not going to be able to show as being real. I mean, he didn't even believe me when I told him the lever oscillates, so come on. I'm pretty shocked at his lack of knowledge. I'm shocked at how irrelevant and stupid you are. Especially as he said a few times that he was a machinist in a workshop. Yeah, again, I don't want to, blow my own whistle and I'll do all that kind of crap, okay? But even it's, I was 17 years old, okay, working in a machine shop, doing printed circuit boards and doing all kinds of stuff. And, we were building, the little shop built robots, basically, for manufacturing. And I came up with a couple of ideas at 17 that, the guy patented into machines. My idea. The guy who owned the shop. I wasn't in it for the money at that time. I was just, trying to get by, just to find a place to live. So I actually lived, I lived in a house that had a machine shop in the basement. And it was, like I said, it was real machines, okay? And these are, 20-ton milling machines and shit. It wasn't little shit. But whatever. It's none of your fucking business. I'm just saying, you're fucking such assholes. You think I'm stupid. Well, fuck you. I think you're dumb. Okay, there. Can we be done with the fucking idiotic argument about how dumb you are? Or do I have to make video after video about how that dumb fuck you are? Jesus fucking Christ. Because you can make up words like moment of inertia. What the hell do you think happens when something hits something? What's the moment of fucking goddamn inertia? Okay, in a Newton's cradle. This ball comes in, hits, this ball leaves. Now it leaves at the speed of sound in steel, in the sense that that's how long it takes, the speed of sound in this tiny amount of distance. So in about a trillionth of a second, this hits and this leaves. What's the moment of inertia, you fuck? What the hell are you talking about? What the hell could that mean to anybody when they've seen a Newton's cradle? What the fuck are you talking about? Moment of inertia. There's no moment of inertia. There's simply energy in one object and moves right into the other fucking object, for fuck's sake. There's no moment of inertia. Jesus Christ. Fuck these people and this bullshit. This fucking rhetoric. Scalar versus vector. Just made up. I don't even know how you conceptualize energy that you could actually think there's something like scalar energy and it doesn't know where it's going, but it's ready to go anywhere. I'm scalar energy. I don't go anywhere. I just all of a sudden, boom, and I go. And I turn into momentum. But wait a minute, I'm not momentum. I'm scalar energy. I mean, it's just too fucking silly. It's a cartoon that wouldn't even make any sense. SpongeBob makes more sense than you fuckers. Alright, let's see. At 2040, you indicate that you are considering an inelastic collision only. So what the hell's the difference? But he's really not considering only one. He's doing the math for one and this and that and all this other crap. But he already pointed out how, yes, he can make the stuff stick, blah, 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 do it different ways. I'm not too comfortable with him sticking foam on the carts because I don't know how much of the energy that's going to absorb. But whatever, we'll see. I mean, it might be so irrelevant it doesn't matter, but it's a little dangerous. I mean, I almost feel better if you put a ball bearing on the front of the cart. So it's a nice solid contact. But anyway, an elastic collision only. Is this correct? If so, I'm wondering why this is the case, because I was thinking we ought to do the elastic collision. So he's already talked about doing both, in the sense he wants to make this rubbery thing, and then he wants to do this solid contact thing. So I don't see where you got that from watching the video. But I'm going to argue. See, he's basically going to argue that somehow when the object hits the lever, it's going to put, if it bounces, it's putting twice the energy in. So I can get a full bounce of 100% of the energy bouncing off. Then I can put 200% into the lever. So that's where he gets the extra free momentum from. So he thinks if he hits the lever with a rubber ball, he's actually going to get twice the momentum into the lever, which I don't think he has any chance of doing. But anyway, perhaps we should just do both. I've actually done calculations for elastic collision, so they think this is something you need to calculate. And I'm just arguing the only calculation is how much energy will moving the lever steal. Because you're basically spinning the lever, right? You're going to hit the lever and it's just like it's going to spin, and you have a certain amount of energy that you've put into that rotation. And you can't get that back. It might send you... Let's see, I might send you the notes over email. Would that be okay? Regarding agreeing if the setup is good, we have to find a case where both of your models agree so that both parties agree. I don't know why you didn't just join the room and then you could have submitted your crap. But anyway, if the setup is good, we have to find a case where both of your models agree. I don't know what this model crap has to do with anything. Why are you focusing on a model when all we're actually saying is, does that happen or does this happen? In this circumstance. And again, I'm going to argue that the one case, that is your double the momentum theory, isn't the kinetic energy theory. All right. There are two different phenomenon. Okay. Regarding agreeing if the setup is good, okay, yeah, let's see, agree the device is calibrated properly. I think in an elastic collision this actually works. The same mass, same radius case works out the same for both models. Says you. I mean, with the qualifications I've already made. I mean, again, we have to accept that the lever is going to kill some of the energy. It's just a matter of figuring out how much. Also, I'm skeptical that you can treat the lever as a massless rod. Well, nobody said you could, so that's so, I mean, you're way behind as usual. And the carts as point particles. Well, I don't know who's doing that. I suspect you have to know the true. Here we go again. Moment of inertia. The magical moment of inertia. There's no moment of inertia. Okay, of the carts themselves, if we are to get accurate predictions, I just don't even know how anything could be relevant beyond mass and velocities. And we're just going to argue that the friction is not deep. So yes, you always have to get over the friction, the static friction. Now, if we could do the experiment in space, we wouldn't have to worry about static friction. All right, and the carts are very complicated shape, so I don't know how the shape of the carts could make any difference at all. This might complicate the calculations a lot. Okay, so let's see what the reply is to that mush. Okay, this video is going longer than I hoped. Anyway, I am planning on doing both experiments under a variety of circumstances. The completely inelastic is actually the easiest to analyze, including with the moment of inertia. So I would argue that's a little... The completely elastic is the hard thing. So he's leaving the... yeah, everything is rigid. Okay, that's the one I want. Of the completely inelastic. That's the one I want, right? Because the springs or the elastic shit is the one that does the reflecting, and we really don't want that. Okay. Inertia of the non-negligible bar. So again, this moment of inertia coming up again. It's a mass and you have to move it a velocity. That's all you have to figure out. It's a solid object. You're going to move its little atoms. How many atoms does it have, and how fast do I, on average, have to move them? That's all we have. So it's just another cart. The lever can be just considered another cart in the way. I have to hit the first cart before I can hit the second cart. The first cart is the lever. Then I get to hit the second cart that I want to move. But I also talked about how the elastic collision should give mass 2 more velocity. So that's the funny part, the free momentum part. But still not enough to violate conservation of energy. But it sure as hell violates conservation of momentum. So this is another prediction that my model makes, which we can test. Well, I'd argue it's your model because, frankly, I haven't heard a regular physicist say that kind of stuff. So I certainly haven't. I haven't seen anywhere where anybody implied levers are only 50% efficient. I think it's a pretty well-known fact that people think levers are pretty close to 100% efficient. Okay. Also, that's the one that DS is specifically making predictions for. I'm not sure he is. I just can't imagine how somebody can't recognize that I've been pointing out what the lever is going to do for 2 years. I mean, I've been making the prediction that yes, I can convert a 5-ton train into a 10-ton train going 5 miles an hour, or I can convert a 10-ton train going 5 miles an hour into a 5-ton train going 10 miles an hour. And all I have to do is do that, and I've defeated your theory. It's difficult to tell because we're not using the same terminology, mainstream terminology. No, it's difficult to tell is because there's absolutely no experimental evidence recorded by science. Science hasn't given a shit about any of these subjects and hasn't done any of the experiments. I was under the impression that he had an elastic collision in mind. I have, yes, exactly. No, I have inelastic in mind. Why would I want something elastic? That's the bouncing stuff. I don't want the bouncing stuff. I want the Newton's cradle. So in a sense, it is it's inelastic. I mean, that's what we call it, but obviously all the energy just goes one way. The word elastic and inelastic are really sloppy. But it just happens that when you send a 2x mass, 1x radius, the one end with the 1 mass, 2x radius on the other end, all energy transfers to the other end 100% in the ideal case. Bizarre. I was thinking that was his prediction for elastic case, but perhaps I'm mistaken. I don't know. You're just so full of crap here. It's just a pretty simple argument. I'm making two arguments, right? The lever works. I showed it oscillating. I'm saying it does the same thing when you launch stuff. It doesn't change any. So you put a, you put a force in, okay, at a point on the lever. You can choose to gain different forms of momentum. You can put a heavy thing close and it'll go at slow velocity. You put a little light thing far and it'll go at fast velocity. But you will conserve the momentum. That's my whole point, is conserving the initial momentum that goes in comes out of the other side if you locate masses in the correct locations. Oh, fuck. And what else do I want to say about that? Oh, I had another point. It has drifted out of my grasp. Alright. Shit. Alright, we'll just let it go for now. Alright, he said he didn't want any bounce. I said explicitly over and over, I don't even expect any. So if you do the experiment and you put everything in the right locations, there shouldn't be any bounce, just like there's no bounce in a Newton's cradle. A Newton's cradle doesn't have any bounce, okay? The mass comes in, hits the other mass, moves it out, no bounce. It shouldn't bounce because you're basically converting the mass velocity ratios. You're saying, I'm going to compensate for this fast acceleration by deceleration by creating a slow acceleration in the heavy object, or vice versa. The slow heavy object comes in and I'm going to convert every movement it makes into a faster, a twice as fast acceleration. So every slow movement here will be a fast movement here, so it will be able to smoothly push the energy through. I mean, how many times have I said this? Shit. All right, got it, thank you. Okay, he said he didn't want any bounce. Well, I'm saying if you're going to do the bounce argument and say you're going to create free momentum because you're going to put 2x the energy into the lever, I'm saying go bounce all you want. I want the bounce. If the bounce is going to show you making free momentum, please show me some bounce. All right. Oh, 10 replies to this. This moron's comments, right? Keep things simple by eliminating gravity. We have already done that, moron. My understanding of this debate is that you need to do the experiment in horizontal. Didn't we already do this? How could this comment be here again? I thought I already read this. No, it's just he's doing the same thing again. I think you should have explained to him that you will use R. I don't even know what that is. Theta? I don't know. In circular polar coordinates with the horizontal XY Cartesian plane rather than vertical XZ, XZ, Cartesian. However, I suspect that DS won't even understand that. That's right. I don't think the angular momentum is going to mean a goddamn thing. The damn lever is going to be a meter long. How much rotation are you talking about here? It's a tiny percentage of the action of this lever. It's not going to be a factor. And again, even if it was, it doesn't matter because you've already demonstrated that the actual linear velocity is going to be proportional. The half mass will be going twice as fast as the whole mass. So why is there an issue anyway? The angular momentum is going to be the same. These people are just so full of shit. When some of these objects follow circular trajectories, obviously it's not going to be very circular. There's a tiny element of circularity, okay? It's a tiny element. Okay, in a vertical plane, they may think the projectile motion that uses XZ coordinates in the 2x plane and get confused. I mean, it's just so fucking off the subject. So anyway, let's see. So this guy says yes to Michael. So I don't know, maybe something's missing here. Yes, Michael showed the experiment will be in the horizontal plane, and D understands this. So I don't even know how this JG guy can't get that. However, there's still gravity, but it just plays a lesser frictional role. I don't even know how it plays any role at all, except, what, for the carts a little bit? I mean, the bearing isn't going to be affected much by gravity, so, good luck with saying you can figure out how much gravity is going to take out of the bearing. The structure of the beam will affect the results. Well, that's a duh. A hollow beam is a given because he wants low mass to fit his model. I want low mass because the only way you're going to see anything is to reduce the mass. I mean, to see anything like a clear, what you want is to get as much conservation as possible. And you're not going to be able to get the conservation you want if the lever's too heavy. Okay, if he wants minimal bending in both vertical and horizontal directions, vertical, I mean, it's just too silly. He should choose a box beam. If he wants more stiffness in the vertical direction to counter gravitational bending, I mean, this is just such a non-issue. Any gravitational bending is not going to have a damn thing to do with the experiment. I mean, it's just too silly. Moments that lead to friction on the bearing. Says you again. Doesn't mind about bending in the horizontal direction so much he can choose a H-shaped beam. So whatever. All this mush over the simple thing is you want something engineered to be light and rigid. That's not, without going to carbon fiber, we're just looking for something light and very rigid. It's not complicated. Okay, he's 15 comments to himself here, pretty much. Ancient Chinese used, whatever this is, maganal of sage warfare, also called the traction trebuchet. So you want to get into arguments about trebuchets now. Okay. So where's the kinetic energy in that mechanism? Yeah, I don't see it anywhere. Okay. It took lots, it looks a lot like a simple lever powered by a rope tension. Well, actually, it's not a trebuchet then, right? I mean, that's a catapult. I mean, trebuchets swing because you have a weight in gravity. All right. You can see it, and the other ancient, I don't know what this, siege engines in action, scale models on YouTube, blah, blah, blah. How exciting. Let's see. I'm just saying that my understanding is the word trebuchet, okay, does have to be a gravity fed mechanism. You're taking a very heavy weight, you lift it up, all right, and inch by inch, okay, using leverage and different mechanisms, gears, and then you just drop the weight, the very heavy weight, on a very long arm. Okay. One more thing. Oh, fuck. The beam has to be aerodynamic. Okay, so this is too. There's no beam isn't going to be moving fast enough for aerodynamics to be a subject. So you really are never on the subject, are you? The hooks and loops of the Velcro would act like springs and dissipate the energy. Yeah, it is a danger. But it's only a danger really when things bang straight into each other. So if you bang two things right into each other, both having energy, then you're going to get a lot of this. Okay, and all the energy has to be essentially dissipated by the Velcro. But if you're really doing this, then all of that action will end up going in the direction that you're moving. So you're going to lose a lot less because it's yielding. It's not reflecting the energy. Reflections have to dissipate. If it's not reflecting, it doesn't have to dissipate because it went into the object. Okay. The change in momentum impulse is converted to pressure stress in the spring. There's no springs here. Okay, the spring is like a system of levers. Oh, fuck. End to end. So is magnetic repulsion a system of levers? I mean, it's just too silly. Okay, I know why the subject changed. I don't know why the subject changed. DS keeps changing the subject, so make your accusations fine. I say horseshit. This was originally about levers, wasn't it? Yeah, and until he brought up my 10 videos. Okay? So he brought it up. I didn't bring it up. He brought it up, shithead. Okay, Eddington experiment, another change of subject. Yeah, and it only takes a second, right? It's really, and he didn't discuss the subject. So I'm just using it as another example where clearly all of you people accept things as true without seeing any real evidence. And even though over the last 100 years our technology has insanely advanced, and we're to the point now where we have 400 times better seeing from space with our satellites, and you don't need an eclipse, and the experiment only takes 5 minutes, and your science that you're defending couldn't care less. So it's the most famous unrepeated experiment in scientific history probably, and you're okay with that. Even though we have 400 times better resolution, 400 times better technology, 400 times, not 4 times, not 40 times, 400 times better technology. And you don't think it needs to get done. Oh, okay. That's the difference between you. You're a fableist. I'm not. Okay. His purpose for all of this is to waste other people's time. So, this coming from somebody who calls himself the loser. So whatever. Don't fall for it. So what, he's discouraging conversations about elemental physics. Nobody should have a conversation about any of this. Nobody should talk about it. Nobody should research it. Nobody should do any experiments. Just an amazing asshole. He claimed to offer $4,000 for anybody. No, I didn't do any of that. I offered very specific people money because they could produce very specific interest in the subject. So obviously I said people have very broad viewership of their channels. I offered them a very good payment for this subject to get a broader audience. And that's all I wanted it to have, was a broader audience. So smarter people than the loser would be opining. That's what this subject needs, is smarter people to be opining than the stupid stench, the stupid putrid scum that you are. Okay, anyway, who does the experiment he requested. So that's just a lie. It's clearly a public page on my website where I ask for the subject to be paid attention to. All of the emails about doing the experiment have been private, and I have made the public statement that if you're interested in doing experiments, I am willing to pay you. Okay, but you just have to be it has to be a reasonable price. But yeah, it'd be really nice to get these experiments done well. But if you're going to do them in a Brozosian manner, I'm not going to pay you. All right, it is rational that he does the experiment for himself with his money instead. So again, why is it my responsibility? First I'd ask. You're claiming truth, and yet you don't have to produce any evidence. Why do I have to produce it? You have millions of scientists, billions of dollars, hundreds of thousands of laboratories, and I'm supposed to prove physics. You don't have to prove anything. Oh, okay. What a fucking idiot. What a loser. Alright. This would be really ironic advice if this was one of the limitless accounts of Brozo. Yes, it is, but whatever. We know Brozo himself doesn't have limited accounts, but he defends people who do, which makes him such a piece of scum. He defends people who invade your privacy. He defends people who do disgusting and rude things on the internet, because he himself is a fucking kind of thievy, crooked, conniving, scheming, scummy human being. And he has a real affection for people who piss in your food at a restaurant or something. That's his kind of fun. He thinks that's humorous. Yeah. That's the kind of trash this fucker is. Alright, anyway. Disgusting human being. Anyway. With kitty toys in his living room. Yeah. Okay, so anyway, enough of a video. So, yeah, so I'll attach the other comment video, and this will be a preposterously long video. So, that's the way that's going to be. It's not that preposterous, but yeah, it's a lot of crap. But the beginning of the video was about some of the real subjects, so it's still a good video. It just has, it just has some shit tied to it. Okay, anyway. Yeah, well, that's enough. Just hit the button. So, like I said, I thought it was a good conversation. I think there needs to be more of them. And, they just have to be more specifically focused. Alright, time for another draftphysics.com video presentation. So, yeah, I have a little more time than I thought, so I might as well finish these comments, so my bad. But reading them, I'm just saying, oh shit, this is just such mush. So anyway, this JG guy. Let's assume you were right for springs are magnetic energy. Well, let's just use one example. Was stored momentum, aka stored motion. Yes, it's the motion that causes the effect. The momentum pushes. I don't know. It's in foot-pounds, momentum. Foot-pounds. It's pressure. Then on what trajectory is this change in motion going in? Well, with the magnets, it's kind of obvious, right? So if you think of a magnet as being like a sun, for example, and there's another sun, and they're both producing energy, and you're pushing them closer and closer together, and the energy is bouncing back and forth between them, and it's creating extra pushing power against it, so it's like compressing air. So obviously that would be the analogy. So obviously if I'm pushing them together in this direction, that's the direction of the force. Duh. God damn it. It can't be a linear trajectory. Why not? What prohibits it from being linear? Otherwise there would be no storage. Why isn't there storage? If I compress a vessel, a cylinder, I can compress it linearly in a cylinder. I mean, I'm pushing this way. The pressure is maintained because of the other elements that are containing it. So these are containers. Springs can only absorb the energy in the way the spring is formed. If I press on the spring the other way, it's not a spring. It doesn't store the energy, it just crushes the spring. I don't, what the fuck? So it must be circulating around some surface. So the example is like the tuning fork, right? I take a tuning fork and I put a spring in between it that's compressed. Now, what's really happening? The spring is certainly pushing on the two surfaces constantly, just like you're pushing into the ground from gravity. There is a force. Now the question is, where does the force go? Well, it obviously goes right around and pushes back in again, right? So, I mean, it doesn't go anywhere. It's got to be circular. The stress of the steel is going through the steel forks, and they're just doing the same thing back at each other, okay, constantly. And I can do that for 10,000 years, and then I can just break the fork off and the spring flies off. What's so complicated? What are the surfaces? So I don't even know. This comment is so, fuck you, I don't even know what the hell you're talking about, frankly. So I'm removing the comment just because it's too stupid. I mean, and I answered it. Alright, so negative momentum isn't what you think. So says you. Okay, I'm just saying you can play these word games all you want. They're clearly stating, okay, that somehow I have an object, and if I make it go this way, I can give an unlimited amount of energy that way. I can create new energy out of nothing. These are all explosions. You have to account for the energy. If something's going this way, you have to account for what made it. If something's going that way, you have to account for what caused it to go that way. It can't go that way with nothing. So this whole idea that you're using, okay, where you say I put 100 in, and somehow I can make 133 this way, and I can make 33 that way. Those are real motions in the universe. They don't cancel each other. They don't undo each other. It doesn't make any sense. Okay. It's like the negative numbers, your positive numbers, but I'm not even going to read this to the rest of you. I already read. This is just bullshit semantic word games. With vectors, you only have fixed distance, and you have to flip the direction of the arrowhead is pointing from one side to the other. Blah blah blah. It has to be made out of a real arrow. You only have this arrow going into the experiment. This is all the arrow you have. That's your explosion right there. This arrow. That's it. You're saying I can make more arrow over here, and then I can make another little piece of arrow that goes over here. And somehow that makes sense to you. I'm saying that's preposterous. I mean, you can get into a relativity argument, and maybe you'll have some ground here, because you can convolute something so much. But I still can't even imagine how. I can barely imagine it. All right, so let me just say that much. But you have to take it on face value. For me to create something going this way and for something to go that way, I have to create an explosion that has a certain amount of momentum. I can't make an explosion that just goes this way. Okay, and let me think of the way to say it. I can't make a device that will produce their result. So they have 100 momentum. Like I like coming in this way. If I came in this way with 100 momentums and I hit two objects, I can only give them a portion of what I have. I can't give them 100 this way and 100 that way. You get it? I mean, I only have 100. I can't push it through, have two things fly off at 100 each because they're in opposite directions. Opposite directions doesn't mean I don't have to account for the energy that's going that way and the energy that's going that way. Oh, fuck. So all you have is the 100. If you have a total of different momenta, even pointing in opposite directions, you are finding the average momenta. Says you. There's no average here. The gun's recoil and the bullet, you don't average them. Then multiply by the number of different masses in the system. So again, this is just such bullshit. mv plus m negative v equals 0. So again, more crap about how I can negate something. Okay, the former meaning that the two opposing forces are on one mass. So what are the opposing forces here? I mean, that's another one of your inventions, okay? I mean, yeah, Newton said it poorly. You bang a Newton's cradle, you get exactly what you expect. 100 in, 100 out. You're saying I can do a Newton's cradle and I can create more out by just creating a reflection, which is more energy. I mean, again, you really think you throw a ball at a wall, two momentums goes into the wall, so the wall doesn't yield. The less the wall yields, the more I get reflected back. So how does that make any sense? The wall absorbs more energy, and yet I get more energy back. Isn't the more sensible explanation that the wall just is reflecting the energy? Just like the tuning fork is just, taking the stress and putting the stress on the other side. And the latter meaning that the two masses at different positions are moving in opposite directions. Their trajectories could even be parallel instead of head-on. So you think it is possible for me to put 100 in and get 133 going that way and 33 going that way, that it could be parallel. Good luck with that. Anyway, the average momenta, 2 divided by 2 equals 0. So again, just playing a word game. Where the dash means different positions, same time. Just baby talk. We already know what MV is. So positions are irrelevant. I just don't understand, sorry, I don't get what I don't see how there's anything in there that makes any that does anything to resolve the problem. You have 100 going into the experiment. You have 133 plus 33. You have 166 coming out. You say that's not an explosion. You say that's not an event. It didn't take energy to make the 33 going that way, and it doesn't take extra energy to make the extra 33 going the other way. I'm saying, sorry, I don't see how that's possible, frankly. It's just silly. All right. Let's see, I think I agree with you that the mass increments should be simple whole units and nothing should be left to assumption. Well, it should be really clinical because, yes, it's a really important experiment, frankly, if it's true, because we can all have free momentum. Yeah. Like how he's choosing velocity. You can't get on a... Can't you get on a live with him and do it virtually together? Well, that doesn't sound like much fun. I'm saying there's something fundamental about the experiment that's shit, so I want to do it in different ways. I don't want to do it the same way over and over again. All right, I want to challenge the experiment. All right. He likes to act very thorough with how he talks, but maybe two brains should get in on it. Well, I guess you're kind of behind. He's actually doing a live stream in just, an hour, where he's going to discuss how he's going to do a lever experiment, and he's soliciting input, okay, on do's and don'ts and such. Okay, I'm about 25. I mean the video, he won't admit what the video's about. I mean, the whole point of doing the lever experiment is to prove levers don't conserve momentum, because that's the only choice they have. They have to prove levers don't conserve momentum to validate mv squared. Okay, I'm about 25 minutes into your video. Well, it's not a good time to comment then. You should just play the damn thing. Just FYI, the top chart clearly is labeled velocity with units. Well, I focused in on the charts and they said both of them, one of them said momentum and one of them said some other crap, but whatever. The bottom chart clearly is labeled momentum with units. Okay, you can say these things. I'm just saying we can see the velocity. Yes, it's a velocity on the chart. I'm saying what velocity is used to create the second chart. The second chart is being created by selecting a velocity. Okay, maybe it would help you to tilt your head sideways. That wasn't terribly useful. Alright, so we'll get rid of that one. That's not saying anything I need to hear. Well, anyway, I'll get rid of both of them, frankly. I mean, this is obviously wrong because, yes, he is doing a live stream. But whether we're collaborators is that's a real stretch. Because he accepts really shitty evidence. I mean, he won't even tell the Gosling guy that his velocity detector has a fundamental flaw. That is, it can make errors in the forward direction all at once, and you won't be able to detect them. Alright, so velocity measurements were at the top of the graph. Yeah, we did all this, right? So he talks to his viewers like, yeah, we did all that. Okay, so I guess we're done. Let me just check to see if there's anything new. Yeah, maybe I'll attach this video to something, or maybe I'll just throw it in the garbage. No. I guess I'll attach it to... I'll make a composite video of some kind for some other day. Let's see. Okay, so that's some nut talking about fucking whatever his name is, Miles Mathis. Oh, Jesus Christ. Alright, that's me, of course. Sorry, this is the one I want to see if there's anything new at the bottom. 10 hours ago. Nope. Okay. So, good if I believe we've completed my task here on Earth for now. Alright, so we'll see if there's any point in uploading this. I guess since I deleted the comments, I should upload it.